Hello everyone, my name is Kathan and today we'll be discussing the problem Grid Coloring 1 from the Introductory Problems of the CSES Problem Set. Let's begin. Let me read out the question for you. We are given an n by m grid where each cell contains one character A, B, C or D. So a cell will consider only one of these four characters A, B, C or D. For each cell you must change the character to A, B, C or D. So we have to make some changes. That too, the changed values also have to lie in this set A, B, C or D. The new character must be different from the old one. Okay, so you must change the cell, right? So if a cell is A, it has to be changed to one of the B, C or D. A task is to change the characters in every cell such that no two adjacent have the same character. So we have to change the grid cells in a way no two adjacent grid cells have the same character. What do you mean by adjacent grid cells? So for a given grid cell, its adjacent will be top, down, left, right. So you don't have to consider the diagonal elements. That is what I'm trying to say. When they say adjacent cells, mostly they mean four-way adjacency: top, down, left, right. If diagonal elements have to be considered, they will specify it explicitly. But since it is not specified, no two adjacent cells have same character means this four-way adjacency, right? Two cells are adjacent if one of them lies in any of these four directions. And the first line, the input contains nm, which is simply specifying the rows and columns. The next n lines will have m characters, so we will specify the grid basically. And in the output, you have to print n lines. You have to print the same grid in which you have changed the cells in a way no two adjacent cells have same character, right? So yeah, description of final grid has to be printed, and you may print any valid solution. If a solution doesn't exist, just print impossible. So if you are not able to come up with a solution, you just print impossible. The constraints here you can see n and m are less than equals to 500. So how many total number of cells can be at a max? It can be 500 into 500, which will be 25 into 10 power 4, which is 2.5 into 10 power 5. So you can traverse this matrix once. That's what it says, right? You can also do some logarithmic number of n into m operations. Yeah, so the example they have given here. So let's just go to the iPad and try to understand it. But the question is pretty simple. You are given a matrix in which each cell has one of these four values. You have to change it, each of the cells, and you must change each cell. Like every cell has to be changed. That's what it is specified, because a character cannot be same as the old one, in a way that the new grid that you obtained, every two adjacent cells have different characters. Fine. So let's just try to understand this question a bit more. First things first, you knew that n and m were less than 500, right? So they were less than 500. So the maximum number of cells that you will have will be n into m, which will be 25 into 10 power 4, right? So all in all, the total number of cells will be 2.5 1e 2.5 to 10 power 5. So that says you can come up with the order of n by m solution. That is, you can revisit the grid once, or you can also have some logarithmic factor here. So you can also have some log n into m. Yeah, maybe I should write below. So you can also have log n into m into log nm. So yeah, I mean, this is a good bound on the time complexity. Now let's try to understand the test case that they have given. So the question is, you will be given a grid like this. Okay, every grid element will only have one of the four characters, either A, B, C or D. The capitalization is important, right? So A, B, C or D in capitals. You have to change the grid in a way. You see in this grid, firstly, each cell will have a different character than it has in the original, right? So each cell has to be changed. Each cell would have been changed, right? So one condition here is each cell must be changed, right? Each cell must be changed. So here you can see this A is into C, this A is into D, this B is into D, and so on and so forth. You can verify it for yourself. And the second condition is no two adjacent characters, no two adjacent cells have same character. Okay, so you see here any two adjacent cells. For example, for this C, what are the adjacent elements? This guy, this guy, this guy, this guy. So top, down, left, right. Right? For this guy, top, down, left, there is no one right. So you can see here, this B, top, left, right. So no two adjacent characters, no two adjacent cells here will be same. So these are two conditions that you satisfy. You have to change this in a way. Each cell must be changed and no two adjacent cells have to have same character. Now what is the brute force that you can think here? Like what is the most dumbest solution that you can think? If you're following this playlist well, you could maybe try every possible combination, right? So what you can do is, for the first cell, you have 4 options, right? So not 4 options, you have only 3 options, right? Because the first guy has to be changed. So for the first cell, you have 3 options, right? Similarly, for the second cell, you have 3 options. Similarly, for the third cell, you have 3 options. So on and so forth. For every cell, you have 3 options, right? So you can come up with a recursive solution which actually traces all of these possible paths. For example, for first cell, you have 3 options. For all these 3 choices you made here, you again have 3 options for the second cell, right? So on and so forth. So you can come up with the recursive enumeration here, which will be like, at the base case you will have considered all the possible cells, right? But what is the time complexity here? Like, can you try estimate what is the branching factor? The branching factor is 3, right? Because you are spanning 3 at every level, so branching factor is 3. And what is the total number of levels that you will get? You are considering all the possible cells, so it will be 3 into n into m. So this definitely is a humongous time complexity, because n m are going 1e5, so you cannot do it. If n and m were less, maybe 5 or something, 5, 10 something, you could have maybe thought about the solution, right? But this cannot be approached. But yeah, it's a good way to think about brute force. So all the possible combinations are 3 into n into m. That's one way. Okay, fine. If this is not possible, then what next? What next can come to your mind? So we have a grid here, right? So we have a grid. Fine. So if you cannot do the brute force enumeration, what can you do? Now, a greedy strategy is, you can say, on the play here, which you can come to your mind like this. So what do you mean by greedy here? So greedy says, when you are making a choice, you don't care about what previous choices you have made, right? So you don't consider the previous choices. You're just assuming, if I make a, you can say, locally optimal choice, it is gonna give me a optimal solution, okay, the global optimal solution. If I just fill this cell correctly, this cell correctly individually, I might get the, like, that is my, you can say, assumption. If I just do my bit at every level independently of others, I might get the globally optimal solution. So that is the main idea of greedy. Now, what is a greedy strategy then? The greedy strategy here can be just fill row by row. Just fill row by row. Yeah, just fill row by row, column by column, right? So fill row by row, column by column, and see what can you do. So what I'm saying is, you go to this guy here, you see what elements are not allowed. So one element, this guy is not allowed, then this guy is not allowed, then this guy is not allowed, then this guy is not allowed, this guy is not allowed, and depending on, you can make a choice there. I know it's a bit vague, but be with me for a while. So this strategy can come to your mind. So let's just try to see, like, what I'm trying to say more concretely. Let's say I have a grid here, and I try to fill cells row by row, column by column. That is top to bottom. That is top to bottom, top to bottom, left to right. Alright. So this is how I try to fill my grid. So this is the greedy strategy. Now let's say I have filled this cells like this, and I am at a current cell, which is this guy. Let's say I have to make a choice for this cell. Now, how do you make a greedy choice for this cell? You know, for the fact that when you're here, this cannot be equal to whatever the current guy you have. That is what I'm trying to say here is, when you try to fill grid of ij, when you try to change the value, because you have to change all the cells, right? So when you're trying to change the value of grid of ij, what all characters are not allowed here? The first character that is not allowed here is simply this guy, right? Then this is not allowed. Whatever you have above it, this is not allowed, this is not allowed, this is not allowed, right? In other words, current, whatever value you have is not allowed. One left to it is not allowed. One left to it is not allowed. Whatever you have there. Similarly, whatever you have to its right is not allowed, right? This guy is not allowed. Then whatever you have above it is not allowed. So left, right, top, and whatever you have below is not allowed. Left, right, top, bottom, right? Cool. So you might say that when we try to fill, or you can say change grid of ij, when you try to change grid of ij, we have 5 not allowed characters, right? You can say at max 5 unique not allowed characters. Not allowed characters, right? The 5 candidates are there which are not allowed to be filled here. Okay, but is it really the case? How are you filling again? You are filling top to bottom, left to right. So when you're filling this cell, this cell is not filled. This cell is not filled, right? So what I'm saying is, you really don't need to worry about this cell because this is gonna be changed anyway, right? So this is not the candidate option here. This is not the candidate option. So you can safely ignore the right guy. So you can safely ignore the right guy because this is not filled. Then similarly, the bottom guy is not filled right now. So you can ignore that as well. Right? By the greedy strategy, we are filling it left to right, top to bottom. So when you are at a cell, yeah, of course it cannot be equal to the current value you have. Of course it cannot be equal to the above value you have because you filled it. Of course it will not be equal to one value before it because you just filled it. So these values are fixed, right? So because you have filled this strategy, according to the strategy, we are filling values top to bottom, left to right. So these values are fixed, right? It cannot be equal to any of these three. So this is not actually true. Only 3 not allowed characters are there at a given cell, right? Why I didn't consider it? Because this value is not filled right now. It will be changed later on. You can worry about this value when you are here. You can worry about this value when you are here. Okay. So all in all, what I'm trying to say here is when filling grid ij, we only have not allowed positions. Maybe call it, let's say, not allowed. The not allowed positions are the current, or you can say the grid ij itself, one left to it and one above it, on top of it. So current is simply ij cell, right? The cell ij. What is left? You have to go one step back. So it will be ij minus 1. What is top? You have to go one step above. So it will be I minus 1 j. All in all, it says at most 3 unique characters, right? So when you're trying to fill a cell, you can have at most 3 unique characters which are not allowed. But how many total characters you have to choose from? Total characters you have to choose from are A, B, C and D. You have 4 characters to choose from at a given cell. Look at the strategy, like not just this cell. You look at any cell. You need not worry about. You only have to worry about this guy, this guy, this guy. You don't have to worry about 3 cells, right? 3 cells. This guy, like the current cell, cannot have the value which is already present. One guy above it, one guy before it. So at most 3 unique characters are not allowed at the current cell. But we have 4 characters to choose from. It simply says is you will always have a character that can be placed in grid of ij. So the answer always exists because we have 4 unique characters, and by the greedy strategy that we have developed, so it automatically proves also that for every cell you will have 4 characters to choose from, and at most 3 characters are not allowed, right? So the proof is in this strategy itself here. Let's see a dry run of the strategy first, then we can see the pseudocode, time space complexity discussion and the final code. Now consider this example. Let's start from the first cell. So for the first cell that you have here, A, what cells, what cell values cannot be allowed here? First will be, so let me just write the not allowed cells here. So not allowed characters. So A is not allowed. Then one guy above it, one guy before it, but there is no guy before and above it. So this is also one important edge case, right? So here, if you go out of bounds while considering left and top, fine. You don't need to consider anything. So you have to first check that left and top are in bounds, right? For example, in the boundary cells, there won't be in this boundary cell there won't be any left. In this boundary cell there won't be any top. So that I guess was assumed that left and top will be considered if they are inside the grid. So for this guy only A is not allowed. So what you can do is you can pick whatever, like the total, you can say the global set we have are A, B, C and D. So these are the 4 possible characters that we have to choose from. The first guy, what you can do is, maybe I can write it here itself. So first guy you can choose B, right? So let's come to this guy. So for this guy, you cannot have A, right? So maybe I can write the not allowed set here. So not allowed set I'll write here. So I cannot choose A. Then one before it. What is one before it? One before it is B. So B is not allowed. B is not allowed. But you can choose C, right? So I'll choose C here. I'll choose C. Fine. Let's move ahead. For this guy, there is no above it, but A is not allowed, and one before it. One before is not A, one before it is C. So C and A are not allowed. C and A are not allowed. So you can pick B again here, right? So simple. You can pick B again here. Fine, no problem. Let's go to this guy. So one you cannot allow is B, and one above it. So this is not A, one above it is actually B. So I guess B is not allowed. So you can happily put A here. Fine. Let's move ahead. So for this guy, B is not allowed. B is not allowed. One above it, one before it. So this time left and top both exist. So one before it is A, one above it is C. So A, B, C all are not allowed. So you can just put D here. Simple. Now let's come to this guy. B is not allowed. One above it is B. One before it is D. So B is not allowed and D is not allowed. You can pick A happily, right? Similarly, let's move ahead for the C guy. So for the C guy, C is not allowed. So C is not allowed. One above it is simply A. So A and C are not allowed. So you can pick B, right? And left was not existing, so we didn't consider it. For this guy, C is not allowed. C is not allowed. One above it is D, and one left of it is B. So B, D are not allowed. So you can put A here. Similarly, let's move to this guy. One before it, which is not C. One before it is C. One before it is A. One above it is A, and current guy is D. So A, D are not allowed. So you can pick a B here. Now you can verify this. All cells are changed because we filled it in a way that not allowed cell, one of the not allowed characters is the current guy itself. Then one left of it and one top of it, right? So not allowed characters was found by current character, one left of it, one above it, and these will have no two adjacent cells with the same character. Fine. So that's about it. So what will the pseudocode? The pseudocode will be pretty straightforward. You can go from top to bottom. So for I equals to 0 till n, and for j equals to 0 till m. So this is, you can say, going top to bottom. This is, you can say, going from left to right. What you can do is you can come up with a not allowed set. So not allowed set, you know, it is what? Left, top and current. Of course, one of those won't exist. So you will have to check whether left and top are in inbounds. Fine. Then the candidate, you can say, will be any one of, you can have a global character set here like A, B, C, D minus not allowed. So any one of them you can pick. You are definitely sure that this, like this subtraction will have definitely the set that we have at least one character, because these three can be give you at least 3 unique characters. And you can fill grid of ij. You can fill grid of ij to be this candidate set. So that's about that. And what is the time complexity here? The time complexity here will be simply, you can say, order of n into m. Right, so here you are doing some work here, but this is all constant m checks, right? So checking this, then this you can say at most the sets are 4 elements. So this is also a constant m operation. So time complexity is order of n into m. Space, I don't think we are using any extra space here, right? So we are just using the input space given to us to store the answer as well. The space complexity here is also order of 1. You might say, okay, order of 4 for this, but it's fine. That is okay. Yeah, I mean, that's about this question. I hope you have understood it. If you did, please comment understood in the comment section right now, and we can move on to the coding part. The code is as straightforward as it can get. So we are taking the input here, n into m, and so this, you can see, I have taken a vector of string, right? So because like each row I'm representing as a character string, and then I'm going through the grid cells I equals to 0 to n, j equals to 0 to m. Then I'm creating this not allowed set, right? And this not allowed set, first I'll insert the current cell, like that will always exist, of course. So I'll insert that current cell, then I'll insert the top cell if it exists, then I'll insert the left cell if it exists. So what is valid is, it just simply checks whether a cell ij is in bounds of grid n into m. So it's simple. You can say I greater than equals to 0, I less than n, j greater than equals to 0, and j less than m. So this is a simple thing, just checking whether ij is part of grid. Once you have our not allowed set, what you can do is you can go through all the possible characters we have. So we have A, B, C, D to consider. So we'll go through that. Then if you find a character which is not in the not allowed set, you're gonna fill it, and you're gonna mark this filled equals to 2 and break, right? So like this is just checking that you have definitely filled the cell. This is not required here because you know the answer always exists, but this I implemented it as a fail safe to make sure that what I thought was I actually implemented, right? So if I was not able to fill here, there is something wrong in the logic that I've written here, right? So this is, you can say, I've marked filled equals to false. Then whenever I filled a cell, I marked it true. and if it was not filled, I printed impossible, although the answer always exists, so this will never be executed. And like, yeah, I mean, once we are done with this loop, we have the grid in our hand, we can just print it. So the input grid was itself updated. So, and then you can print the grid. Time complexity order of n into m, we are revisiting the grid just once, and space complexity order of 1. Fine. So yeah, I mean, that's about this question. If you understood it, if you like the explanation, please give it a thumbs up. And I would love to see the solutions in other languages as well. So how to implement in Python and Java in the comment section. See you in the next one.